Hi folks, welcome to Performanta training program. In this training session, we'll be discussing about what is performance testing, why performance testing is required, and what is the difference between performance testing and performance engineering. Now, before we get into this topic, let's look at an application that we use in our day-to-day life. We have the Facebook, Twitter, and Netflix are applications that we use in our day-to-day life. But have we ever thought of like how many requests are being handled by these applications? So based on the recent estimate, it looks like there are over 2.9 million active user base for Facebook and receives over 10 billion visits per day. And similarly, Twitter has a user base of 330 million active users and receives 500 million visits per day. And also Netflix has over 222 million subscribers and receives a traffic of 1.5 billion visits per day. When these companies build these applications, they did not build an application or they did not have an infrastructure that's capable of serving these many volume of traffic, right? So how did this all happen, right? When they would have built an application, right? They would have built an application which is capable of capturing maybe thousands or some lakhs of transactions, right? But eventually, they introduced a certain optimization, or they kind of build a bigger infrastructure that is capable of handling these many volume of traffic. So these techniques or these scalability or whatever they introduce on the infrastructure, right? All those things comes under what is called as performance testing and engineering. So now let's see what is performance testing. So to understand performance testing, let's try to use an analogy of building a bridge for the public usage. Say for example, we are building a bridge and we are going to give it for the public for the usage. Connecting two different villages or something, whatever it is, right? So when they are building the bridge or when the bridge is completed, right, they are not going to immediately hand it over to the public for the usage. Before they hand it over to the public, right, they need to do some assessment on the bridge. They need to understand how much load the bridge is capable of handling, how many number of trucks or buses or vehicles it can carry, and number of users. If there is a big crowd, how much of a crowd or how much weight it can potentially handle. All these things they have to do an assessment, maybe using some mock or dummy trucks or dummy weight. They have to keep it on the bridge and see if the bridge is capable of handling that load. So only after that complete assessment is done, they're going to release it to the public usage. Think of a situation where they don't do all those checks and immediately hand it over to the public. What might happen? Might result in a catastrophic event. The bridge might collapse or it might crack. When there is a huge crowd comes into that bridge, or so it might result in a loss of lives too, right? So similarly, when it comes to performance testing, or when an application is built, before they release that application to the end customer, it is important that they have to do a complete assessment of how that application will perform, right? So and whether the application can handle the load for a longer time, or if there is a sudden spike of load, the application is capable of handling. So they will be doing all these checks and then only they will release it to the public usage, right? So that's nothing but performance testing. By definition, performance testing is a discipline of software testing that focuses on determining how a system performs in terms of responsiveness and stability under varying workload conditions. It primarily seeks to understand speed, scalability, and reliability of an application. So it primarily seeks to understand, right? So how do we know whether the application is performing good or not? So there is something called key performance indicator, right? We'll discuss about in the later modules. So there is something called key performance indicators using which we can tell whether a particular application is performing good or bad, right? So that is nothing but performance testing. There are different types of performance testing as well: load, stress, endurance, spike, volume testing. We'll be covering this in detail in the coming chapters. So now we know what is performance testing. Now let's try to understand what is performance engineering. Performance testing, we have seen that we are trying to simulate the application to varying load condition and understanding the performance using some key performance indicators. So now we have identified a problem or a bottleneck. A particular transaction is taking more time to respond. For example, let's say the order creation flow, the submit transaction, the last step of the flow, right? It's taking more than 15 seconds or 20 seconds to respond. So in performance testing, it ends up saying this particular transaction is a problem, and they will create a defect and they will close that performance test. And what happens in performance engineering? So once they've whatever the issue that has been identified, right, they need to do a deep dive analysis. They need to do the root cause analysis. So now we know the transaction response time of submit transaction is taking more time to respond. Now we need to look at the technical stack, look down the technical stack and see what are the calls that are getting orchestrated from the submit transaction, and what are hitting the web server, what are hitting the application server, and what are hitting the database layer, and where exactly this problem is manifesting. Is it on the web server layer, or is it on the application layer, or is it on the database layer? So this analysis, all these things comes under the performance engineering framework. So there are various tools using which we'll be able to identify where exactly the problem lies, and all these things comes under the performance engineering. By definition, it means performance engineering is a broader field that encompasses not just testing, but also the process, tools, methodologies to ensure that system meets performance requirement. It involves a holistic approach to understanding the architecture, design, and functionality of a system with the primary aim of optimizing its performance throughout its cycle. And in order to do performance engineering, it is very important that we need to understand the overall architecture, overall the design, in terms of the technical mapping of each call. There's a lot of details that we need to understand in order to do the performance engineering. Because also performance engineering not only pinpoints where exactly the problem lies, it also involves giving some recommendation or fixes for the problem as well. Now that we know what is performance testing and performance engineering, let's try to understand why is it required. So the first key reason as why it is required is because it's part of the software development lifecycle. So in software development lifecycle, there is a phase called testing phase. Under testing phase, there's a branch which is called performance testing. So it's very important. Any product software development life cycle involves performance testing. So that's the first reason as why we need to do the performance testing. And the second key reason as to why we do performance testing is, if an application is built which performs poor, right, nobody's going to use it, right? Even an application which is running successfully, for example, Amazon or Flipkart, which is performing top notch, right? And if you say for a week, or if it crashes during Big Billion Day or Black Friday, right, it will that company will lose the customer confidence, and people will be trying to go for their competitors' website or something which performs well. So these are some of the reasons as why performance testing is very critical for the business. Also, I would like to give you an example. In the past, there was a case study published by Amazon where they said a delay of 100 milliseconds in the page load time resulted in the 1% reduction in the overall Amazon sales. Right. So, and this 1% of reduction in the Amazon sales resulted in millions of revenue loss per time. It's a very big, revenue loss for Amazon. So after this case study was published, right, so everyone started understanding the impact, even this small 100 milliseconds impact, right? So people were cognizant of the impact that this can happen on the overall business revenue. This led to giving a significant importance to performance testing and performance engineering discipline.